Module 1.8, Pressure. We're not going to do very much with force in this class, but we will be talking a lot about pressure, since sound is mostly caused by changes in air pressure. Pressure is defined as force per unit area. In other words, pressure is force divided by area. The unit of pressure is newtons per square meter, or the Pascal, named after the French mathematician Blaise Pascal. 1 Newton per meter squared equals 1 Pascal. Pascals and newtons per meter squared are used interchangeably. How much pressure is 1 Pascal? Remember that pressure is force divided by area. 1 Pascal is 1 Newton of force spread over 1 square meter. If you are looking at a tiled floor with 12-inch square tiles, look at a square that is 3 by 3 tiles. If you're not near a tiled floor, hold your right arm straight out to your side and put your left index finger in the center of your chest. The distance from your right fingertips to your left finger is about 1 meter. Now imagine a square with each side being 1 meter long. Remember that we said a Newton is about 1/4 of a pound? Imagine taking 1/4 of a pound of chopped meat and spreading it so that it evenly covers that 1 square meter. I know, that's disgusting, but imagine it anyway. Would that 1/4 pound of meat, spread in a very thin layer, exert a lot or a little pressure on the ground? Not very much at all. In fact, the pressure of 1 Pascal is about the same pressure as a dollar bill resting on your arm. So, a kilogram is a moderate mass, about a half a bag of sugar. A Newton is a small force, 1/4 of a pound. And a Pascal is a very slight amount of pressure. Despite this, we will see later on that a change of 1 Pascal of pressure on your eardrum results in a very loud sound. The big picture. Pressure is directly proportional to force, but inversely proportional to area. Let's see what that means. Imagine that I am pushing you away from me with the palm of my hand. If I push you lightly, a small force, the pressure on your body will be small. If I push harder, a large force, the pressure on you will be stronger, since force and pressure are directly proportional. Now, let's say that instead of pushing you with the palm of my hand, I push on you with just the tip of my finger. What will that feel like? It will probably hurt. Why? The force is the same, but I have now decreased the area substantially. Since pressure and area are inversely proportional, the smaller area results in a great increase in pressure. Here's another example. Let's say that I was walking my pet pink elephant Eloise on the beach. The average elephant weighs about 4,000 kilograms. 4,000 kilograms translates to about 40,000 newtons. An average size elephant foot is about 1/4 of a square meter. So when all 4 feet are on the ground, they cover roughly 1 square meter. So the pressure exerted on the sand is then about 40,000 pascals with all 4 feet down. When she walks, only 2 feet are on the ground, which is half the area, so the pressure doubles to 80,000 pascals on the sand. Eloise doesn't have much trouble walking on the beach, and as you can imagine, she puts moderate impressions in the sand with her feet. I weigh 60 kilos, which is about 600 newtons. Each of my sneakers takes up about 1/6 of a square foot, or about 0.015 square meters. Walking on the beach is not too difficult for me either, and the impression in the sand that I make is about the same or less than that of an elephant. Why is that? For me, both feet together make 0.03 meters squared. Pressure is force divided by area, so 600 newtons divided by 0.03 meters squared equals 20,000 pascals with both feet on the ground, and 40,000 pascals with 1 foot, compared to my elephant's 40,000 and 80,000 pascals. So even though Eloise weighs almost 70 times my weight, Her pressure on the sand is only twice that of mine. Now, it's a lovely evening and I'm feeling rather fancy, and I decide to wear my ruby red rhinestone-studded stiletto pumps instead of my sneakers. What happens? If I walk on just the stiletto heel, it's about a square centimeter, which is 0.0001 meters squared. My pressure on the sand is now 600 newtons divided by 0.0001 meters squared. When you do the math, that turns out to be 6 million pascals. That's why my stiletto heels put deep holes in the sand, and why it's so hard to be fashionable while walking on the beach. Interesting fact, the pressure of the atmosphere is about 100,000 pascals, more than the pressure of Eloise on the sand. Changes in sound wave pressure on the eardrum range from 20 micropascals to 20 pascals, an extremely small percentage of regular air pressure. So human hearing is an extremely sensitive pressure measuring device. We are able to detect changes of air pressure of 2 times 10 to the minus 9th to 0.02% of normal air pressure. To review, pressure equals force divided by area. Pressure is directly proportional to force, but inversely proportional to area. 1 Pascal equals 1 Newton per meter squared. The pressure of 1 Pascal is about the same as the pressure of a dollar bill resting on your arm.